All right, all right, all right. Here we go. 3D. What? 3D. Crazy. All right, so here we go. We have differentiation, and now we have the power and quotient rules. Um, so let me just kind of take a... Okay, I see what we're getting into. All right, so let's review a little bit about what we already know about derivatives and the big time heavy hitters. So the heavy hitting rules that we know right now is the power rule. And so formally what it looks like is this. If a x has an exponent, generally what happens is the exponent comes down as a multiple, and you subtract 1 from whatever that exponent is. Okay, that's the big rule. Other things that we learned real quickly is we learned about a constant. Like, I'm just literally going to write a number. Any number is going to be equal to 0. Kind of falling into the idea of the power rule. This is technically the power rule, but you'll see this a lot of times. The derivative of straight up x is going to be the number 1. And so that implies that if it has like 5x, then the answer is 5. Okay? So that sort of idea, we know that. What else do we know? We know sines and cosines. So the derivative of sine is cosine. The derivative of cosine is negative sine. So any derivative of a co is a negative. So a co is a negative. So this is negative sine. And then I think the last one that we touched upon was also an e to the x. That's e to the x. Okay. Other things that you probably need to know. So people oftentimes will ask, well, how do you handle square roots and stuff? What's a square root? All right. And the idea behind taking a derivative of a square root is just think of these things as exponents. Like, you know, if it's a denominator, it's a negative. It's something like that. And you can think of it in a simpler fashion. And now that's just a power rule question. So the exponent drops down, and then you subtract 1. All right? So that would be 2 square root x as a denominator of 1 sort of concept. All right? So a lot of times those are the questions. All right. What we're going to be talking about today is 2 different things called the product rule and the quotient rule, the product rule. The product, as in when you multiply things together. So we did already kind of discuss, well, what happens when you have things that add? Okay? Well, when you add something, okay, I'll say that this is u plus v, where u and v are functions that have an x inside. All right, so u is x to the third, v is x squared. What it is just the derivative of whatever the u and v is added up. So addition doesn't affect it. Subtraction doesn't affect it. Okay? Now, multiplication and division, though, play by a different rule. Okay? Play by something different. All right, so let's take a look at what happens when you are multiplying things that have x's in them. So u times v. All right? What you do is it is going to be u prime v plus v prime u, or uv prime, something like that. So that is the derivative of u times the regular old v plus the derivative of the other. So an example of this is this. What is the derivative if f of x is equal to x squared plus 1 times x to the third minus 4? What is the derivative of that? So think of this as the u and this is the v. So when this is called the product rule because they're multiplied. Well, the first thing that you do is you take the derivative of the first, the u. So the u prime is going to be 2x. That's u prime is 2x. Times the regular old v, which is x third minus 4. Plus v prime u, or the same thing, but you take the derivative of the other. So this is the regular old u times the v prime. And that is the product rule. That's what the derivative is, whatever that comes out to be. I'm not exactly sure. Okay? So that is how you take the derivative of a multiplication. And again, we're going to go through many different examples, but the bottom line is this. This is your key to success. When you have a multiplication, it's the derivative of one and then the other. So plus the other. Derivative of one plus the other. Okay. And hopefully I'm not getting that far ahead of myself. What happens when there is a division? What happens when there's a division? Okay. And I call this one bottoms up. Bottoms up. Okay, the v goes up. So we go v to the top. Regular old v. And then it's the derivative of the top minus the vice versa. Okay, minus the vice versa over the denominator squared. So it's kind of like the product rule with the numerator. However, the order absolutely matters, and the v goes up. All right, so what I'm saying is the v goes up. The regular v goes up. Let's see if I can construct a quick example out of this one. Let's say that I have 2x minus 1 divided by 3x plus 5. Something like that. So, what is the derivative? Okay, so again, think of this as u, and think of this as v. So, bottoms up. So, 3x plus 5 comes up, derivative of the top. Minus the vice versa. So, I take the derivative of the bottom times the regular old top. All over the denominator squared. Okay. And I'm not really going to worry about the cleanup method, but as long as you can get the power rule correct and the quotient rule correct, that's really what I'm worried about. So this is your key to success. Bottoms up. The v goes up. All right, here we go. So if you can rewrite it, cool. If you can't, then we have to get a little bit tricky. All right, so here, what I see, this is actually x to the negative 5, so it's easier to rewrite it. And then thus the derivative of this would be negative 5x to the negative 6. Depending upon how they want that written as an answer, this could be negative 5 over x to the 6. Right? Rewrite it. This is x to the 1/5. So the derivative of this is equal to 1/5 x. And again, when I'm subtracting 1, I'm kind of subtracting 5/5 in my brain. Okay? I need to subtract 1, so I subtract 5/5. So that's negative 4/5. Okay, it could look like that, which I'm assuming that's what the answer would look like right there. But it could also potentially look like the 5th root of x to the 4th. I don't think they would write it like that, but they might. I don't know. Okay. Here in this exercise, they want you to do exactly what we did. Rewrite it, take the derivative, and then clean it up. All right, so number 25. Okay, the number is 2/7. So take the numbers out, 2/7. That's not going to change. And then I see that there's an x on the bottom. So that's a 2 to the negative 4. So that's the rewrite. Okay, multiply it down. So that is going to be what? Negative 8/7. Y to the negative, excuse me, as you were, x to the negative 5. Then put it back into the fraction looking kind of thing. That's negative 8 over 7x to the 5th. All right. So this is x to the 1/2 times x to the negative 1, aka that's x to the negative 1/2. Multiply means add of the exponents. So the derivative is drop it down and subtract 1. So I'm kind of like mentally subtracting 2 over 2. And then clean it up. So negative 1 over 2 square root of x to the 3rd. Find the derivative of the function. Okay, so again, rewrite it. Then take the derivative of it. Okay, so I'm pretty happy with that one. So this is 2t, excuse me, to be 2t plus 12t. Because that's how the original problem looked, I'm assuming that's what they want. All right, where are we? Oh, here we go. So u times v. So that's u prime times the regular v plus the regular u times the prime of v. I'll shrink this down so I'm not kind of bleeding into number 3 here in just a second. All right. So here we go. This is 2 minus 10x minus 10x plus 15. This is negative 20x plus 17. It doesn't matter what order you multiply. Like, so if you wanted to say, hey, this is negative 5 times 2x minus 3, that's totally cool. I get it. It doesn't matter what order you multiply in. The only thing that makes any difference is the order that you subtract and the order that you divide. Those are the big heavy hitters. But multiply and add, it doesn't really matter. So again, this is U, this is V. Actually, let me rewrite the original problem. So this is t to the 1/2, and then 1 minus t squared. So the derivative is the derivative of the first times the regular old second plus, and I'm going to drop down the line here, plus the regular old first times the derivative of the second. I don't know how much cleanup they really want here. So this is 1/2 t to the negative 1/2 minus 1/2 t multiply means add, so that's 3/2. And then this is going to be minus 2 multiply means add t to the 3/2. So this is 1/2 t to the negative 1/2 minus 5/2 t to the 3/2, something like that, something along that line. Check my math. All right, number 7, they want you to do the quotient rule. So we have a U and a V. So here we go. Bottoms up, so the V goes to the top. Derivative of the top is 1. Minus, and then you do the derivatives, but of the others. So this time I'm leaving the top alone, and I'm taking the derivative of the bottom. All right, so I'll just kind of write out loud what this was. This is V, the bottom's up, U prime, minus the same thing, but just backwards. So on the first part, you have to take the U prime. On the second part, you take the V prime. All right, and this is all going to be over V squared. All right, so this is what? X minus 5 minus x all over x minus 5 squared. And thus this is negative 5 over x minus 5 squared, something like that. The question that always that gets brought up around this part is, what do you expand, or what do you just kind of keep as a square? What do you multiply together and things like that? And a lot of times you're going to keep the denominator as it appears here, like just the denominator squared. It's no ifs, ands, or buts. It's not that big of a deal most of the time. But you do usually have to clean up that funky numerator that gets created when you do the quotient rule or the product rule, something like that. So yeah, you do have to clean up the numerator. But usually the denominator, it's good to go. All right, here we go. The derivative, bottoms up, derivative of the top, minus the vice versa. So that's going to be 3x squared, and then square root x, aka x to the 1/2. Okay, bottoms up, square root the top and then the other. With the denominator squared. So I do probably have to clean up this numerator here just a little bit. Gravy. So ugly mathematics. All right, so this is 1/2 x multiply means add, so that's what, 6/2, 5/2 plus 1/2 x to the negative 1/2 minus 3x to the 2/2, 4/2, 5/2. This is 3 minus 1/2 is 5/2. So this is 5/2 x to the 5/2 plus 1/2 x to the negative 1/2. Oh, this is just nasty. X to the third plus 1 squared. I'm not going to touch it. That's gross. So much math. Fractions and adding and subtracting fractions. Don't pay me enough. All right. So you got that. F prime of x and F prime C, okay, but you need to use the product rule. All right, so the first thing you need to do is we are evaluating when x is going to be equal to 0 of the derivative. But notice how the derivative is a little bit more complicated. This one is the product rule. So the derivative of the first, the regular old second, plus the regular old first, times the derivative of the second. Okay, now typically this is where I would absolutely clean this up, but I'm not a glutton for punishment. I noticed that this has 2 terms and this has 3 terms, so this is going to be a polynomial that has 6 terms in it. Yes, some of them will consolidate, but for gravy, I'm not in it. I'm not that motivated about it. So what I'm going to do is this is the derivative. I know that I'm correct. Whether it looks like this or a big long polynomial, it doesn't really matter. Because what I'm going to do now is I'm going to evaluate at the point, which luckily it's a nice number, like the number 0. So this is going to be 4. This is going to be -5. This is going to be 0. And this is going to be 2. So all I did is I put a 0 in for all of the x's. So this is going to be equal to -20. All right, so here bottoms up, derivative of the top, minus vice versa. All over the denominator, squared. I'll do one quick cleanup step. Even though I teach calculus kids, you would be amazed at how many people will believe that to be a -4. One of the most basic rules. All right, so that's your derivative. I did a little bit more cleanup than probably what's necessary. And then we are going to evaluate at 1. So what is this derivative at 1? And so this is going to be 1 minus 6 plus 4 all over -2 squared. And so this is what? -1 over 4. All right, here we go. Complete the derivative, et cetera, et cetera, et cetera. Rewrite, differentiate, simplify, all the good stuff. So you can separate the numerator just like they did in the example. So y is equal to 1/3 x to the third plus 2x. You can separate numerators, you can't separate denominators. Or you can, but it's a lot of math. All right, so here we go. Multiply by 3. So 1/3 multiplied by 3 is 1. So that's 1x squared. And then 2x is just 2. And simplify, well, that is pretty simple. All right, next, 6/7. So I pull out the numbers, and then this is x to the -2. So y prime is multiplied by -2, so that's -12. 7ths, subtract 1, so that's a -3. Putting it all back together, this is -12 with that x on the bottom at a third. So this is the x's. So we have 4. You all know that, 4. And then this is top minus the bottom. So this is like a -1 on the x's. So top minus the bottom, 3/2 minus 1 is going to be 1/2. So the derivative is it multiplies down. So 1/2 times 4. Subtract 1, that would be a -1/2. And thus this is a numerator of 2 with a denominator of x to the 1/2. That's it. All game. Okay. So again, the two new things that you need to draw away from this lesson is this. The product rule. What is the derivative of things that are multiplying? And that's going to be the derivative of one plus the derivative of the other. Okay, again, it doesn't really matter which order you go in this one because it's just multiplication and addition. However, when you do the quotient rule, orders of this stuff absolutely matters. All right, so here we go. It'd be the bottoms up, so b goes up, take the derivative, okay, du, and then you subtract and do just the opposite of what that is. Okay, something of that nature. Okay. And then it's over the denominator, the original denominator squared, not the derivative. So those are the two new things that you need to take away from this lesson right here.